Hello, this is the last class review video. This is on class 22. Moving forward, I'll be hopefully making videos on specific problems or concepts that students have asked me questions about. I think many of you will be happy with this video in particular because I am going to write out the mechanisms for SN2 and SN1 under different conditions. We have an SN2 mechanism if you have a primary alkyl halide with a strong nucleophile or base, or strong nucleophile only. SN1, sometimes you'll see it also with a strong nucleophile or base, or strong nucleophile only. But if the nucleophile is weak and neutral, there is an added step to the mechanism. So we'll go over these three mechanisms. What I will not go over in this video is reproducing the two things that I want you to memorize. The categories of nucleophile base, those are the 4 categories, and the decision tree. But I'll be using them in this video, and it will be helpful if you have those in front of you. Okay, let us take a look at our first mechanism, SN2. And a good example of an SN2 reaction is if you have a primary alkyl halide plus a strong nucleophile or base. What can I use? Let me use this one here. And the analysis that you should go over, let's say we need to draw the product. You want to first figure out the type of alkyl halide. This is definitely primary. And then you want to figure out the type of nucleophile / base. This molecule splits up into its ionic pieces. And we have an N minus molecules have a nitrogen with 2 lone pairs and 2 bonds. Your cation is lithium, but that's not important. And if you look at your categories of nucleophile and bases, this is a strong nucleophile, strong base. Get in the habit of figuring out the type of alkyl halide and the type of nucleophile or strong base, type of nucleophile or base, and then go to the decision tree to figure out what the mechanism is. Now, the product is substitution, and if you're not worried about stereochemistry, and we're not in this case, you would get the same product whether you think it's SN1 or SN2. That dot is where the nucleophile attacks. The nucleophilic atom is nitrogen. It carries with it the hydrogen and the ethyl group. In the box, SN2. Let's take a look at the mechanism. SN2, direct attack, meaning there's no waiting for a carbocation to be formed. The nucleophile is strong. The alkyl halide is uncrowded. Therefore, it makes sense that you would have an SN2 reaction. The nucleophile helps kick out the leaving group. And you have your product in one step. We kicked out chloride minus. That's SN2. Your RDS is obviously the only step is the RDS step in this case. That's SN2. When else would you get SN2? If you have a methyl halide or primary and any nucleophile. On the fence is if you have a secondary alkyl halide If your nucleophile is a strong nucleophile, then it will go SN2. We're not really worried about the base personality of these molecules, but I'm going to keep continuing to label it strong nucleophile, strong base. You might as well learn it like that because you're going to need to know those categories with the base portion of it in future classes. There are 4 categories, correct? And one of them is strong nucleophile, strong base. If it was weak, then the secondary alkyl halide will transfer or switch over to SN1 mechanisms. Okay, everyone good with SN2? Again, I'm trying to tell you the conditions that would lead to an SN2. Well, what are the conditions to lead to an SN1 then? I want to get this on one sheet. Let's see if I can do that. SN1. All right, tertiary for sure. But also we went over in class the idea that a stabilized carbocation can also go through SN1. So if you have anything allylic or benzylic, any alkyl halide that's allylic or benzylic, even if it's primary, if it's primary benzylic, it's SN1. Allylic, a primary allylic, SN1. And this would be with any nucleophile. What else do I want to say? Oh, secondary. The one on the fence. The one on the fence, secondary, could either be SN2 or SN1. So how do we make it SN1 if it's a weak nucleophile or base? Contrast those two situations, the situation and the situation. It will tell you whether it's SN2 or SN1 for that alkyl halide that's on the fence. So I said that I would go over the mechanism using a tertiary alkyl halide with a strong nucleophile, strong base. That's this condition right here. Okay, tertiary, crowded. What about this? Strong nucleophile, strong base. Let's do NaOET to practice. Now I don't know at this point that it's SN1 mechanism. What's wrong with my arrows? So we are going to analyze just like we did for SN2. We have a tertiary alkyl halide. We have a strong nucleophile, strong base. Our product is the substitution product, or I will specify on the exam I want this substitution product. But now what about the mechanism, SN2 or SN1? If we take a look at tertiary, automatically SN1. Automatically. Okay. Let's draw the mechanism for this reaction. Is it very different than SN2? Yes, because you're going to go through a carbocation. Without any help from the nucleophile. What do I mean by no help? With enough heat, the bromine will kick off by itself, and you'll get a carbocation in the tertiary position, plus Br minus, and now your nucleophile attacks. In an SN1, your nucleophile waits. Mainly it waits because it's too crowded to hit the alpha carbon, right? This is the alpha. This is the alpha. The product, well, not the product, but the mechanism is that. And we have this. You'll notice that, or you should know that, if you thought this was SN2, you would still get the same product. Just it goes through a different pathway. So just double check that is your ether. Let's label the molecules. Up here you had an amine. This is an ether. And I have the same ether here. I think that's it for the mechanism. Pretty simple. You wait for the carbocation in SN1. What was the SN1 with the weak nucleophile weak base? Why did I keep that separate? Because there's an extra step for this. You have to deprotonate at the end. Let me just double check everything is correct. Let's label the RDS here also. It's a step where you get it's a slow step, and for the substitution, it's a step where the halide is leaving. So the first step in this case is the RDS. All right, last mechanism, SN1. Let me make sure I have the right colors. Orange and pink, okay. SN1. Sorry. And this is with a deprotonation at the end. You'll see why we have to deprotonate. It's to get back to being neutral. And so why weren't we neutral to begin with? Because we attacked, in this case, with a neutral nucleophile. Let me show you that example. Another tertiary alkyl halide. Let's use this one. And I said here, we're going to use a weak nucleophile base with the tertiary alkyl halide. Look at your tables. What's weak nucleophile? What's weak base? It's a neutral molecule, typically with an oxygen or nitrogen. Let me use this one, OH. You're still substituting at the alpha carbon. That carbon would not be chiral, so we're not really worried about stereochemistry. What do I put in the box? Oh, shoot. We didn't do our analysis. Tertiary. And then this is a weak nucleophile base. It's neutral. I'm going to do SN1. Both components actually tell me SN1. Tertiary is crowded, can't attack right away. This molecule alcohol is weak, doesn't attack right away. So everything's waiting, or the nucleus is waiting for the carbocation to be formed. How do you form the carbocation? Give it enough time or heat, you will kick out that halide, and you have this carbocation. Tertiary, great, it's stable. And then we have the attack. And if that nucleophile was an anion, we would be done. But it's not an anion. It is a neutral alcohol. Let me just double check. OH plus. And so with the SN1 on the first page, or here at the top, you notice that it's only 2 steps. Here, we have to add a third step. And you could use another alcohol. I'm going to use the Cl- to strip off this hydrogen, or technically that proton. And now we have our final product. Plus what? HCl. Okay. If you don't remember that you had that Cl-, you could use another alcohol. Okay, and just deprotonate using that lone pair. Okay. RDS we said was at the beginning because that's when the leaving group leaves. It's unimolecular, and there is your example. I think out of the 3, by the way, these 3, most students have slight problems with this because of that deprotonation at the end. Okay, what I didn't go over in this video, and if you have any questions about it, just let me know. We did not here discuss stereochemistry. What are some terms that are associated with stereochemistry of substitution reactions? We didn't discuss backside attack. That's SN2. Or inversion. That's the same thing as backside attack. And we didn't discuss scrambling. When you make racemic mixtures, is that how you spell it? In SN1 mechanisms. Okay, that concludes the videos for these review sessions on the classes. Again, moving forward, videos will be specific on specific problems or concepts that students have asked me about.